Welcome to Icom's video presentation on IC-F3400, F5400 series, using high-level AES encryption. In this presentation, we will explain about the CS-OTAR1, OTAR Manager software, and a little about the CSKLD2 wired key loader. Please note before we start, this video is aimed at the people who already have the radios ready for using AES encryption. In other words, the UT134 encryption unit, and the activation key have been installed. First, let's get the basic concept of the CS-OTAR1. The radios whose encryption keys were loaded by the CS-OTAR1 have two keysets, active and inactive, holding traffic encryption keys for daily voice or data communication, and additionally, the OTAR encryption key, used on the OTAR system to encrypt the keys themselves when they are sent out over the air. Both of the two keysets can store up to 31 traffic encryption keys. But only the keys in the keyset that is selected as active are used to encrypt voice or data in actual communication. The keys in the inactive keyset are intended to be renewed by the OTAR system for the next key cycle. So the OTAR system up and running goes like this. The CS-OTAR1 renews keys in the inactive keyset of all subscriber radios for the next key cycle, over the air. This may take some amount of time, depending on the number of encryption keys listed in the keyset, or the number of subscriber radios. However, it can be done without affecting the running encryption system, as only the keys in the inactive keyset are altered. When the keys in the inactive keyset of all subscriber radios are renewed, it's ready for changing over the active keyset. Switching active keyset won't take so long as renewing the keys, but still takes some time. So by enabling the decryption multiple keys, the radios can maintain communications even with a radio like the third one above, that has not yet changed over active keysets while in the changeover period. The same process is alternately performed on the two keysets every time the keys are renewed. Then, let's look at a typical configuration when deploying AES encryption and the OTAR function into an existing system that has been using standard encryption. Necessary configurations on the subscriber radios are as follows. Enable the OTAR function in the OTAR page. Select the UT134, at the option unit, in the encryption setting page. Set high level, as the encryption mode in the memory channel. Next, prepare a radio, to be used for sending out the keys to the subscriber radios over the air. Enable the PC command function on one of the I/O ports, to communicate with the CS-OTAR1 through the OTAR port. On the accessory port, with the connection speed set to 19,200 baud. Or on the USB port. Using Bluetooth is also possible. However, this radio doesn't have to have the AES encryption enabled, for sending out the keys over the air. Now start the CS-OTAR1, then click New, and select the system type, used for the OTAR operation. The key list numbers in both keysets must include all numbers used in various subscriber radios in the system. So in this example, set the key list number 1 to 10, commonly in both keyset, and fill in unique keys in both keysets. Next, make a list of the subscriber radios, together with the OTAR encryption keys for each radio. Then load the keys in the keysets, and the OTAR encryption key, directory into each radio one by one, as the initial setup. Connect the radio ID 1, and make sure the right programming port is selected, then click OK. Do the same with all subscriber radios. Now the encryption system for the first key cycle is ready. For the second key cycle, just switching the active keyset is needed, because keyset 2 has been also loaded by the initial setup. From the third key cycle, the keys in the inactive keyset need to be renewed by the CS-OTAR1. Open the inactive keyset and renew the keys in it. Random keys can be automatically generated. To prevent disturbing normal traffic as much as possible, it is a good idea to perform the OTAR operation while the system is not so busy. Now all keys have been renewed. Then just switch the active key set when the time comes to start the third key cycle. Some systems, or some of the radios in a system, may not require the OTAR function. In that case, you can use the CS-OTAR1 as just a wired key loader. By using this function, you can load the keys into a radio directly through the programming port. Not only the management TR is the function name, but also any radios regardless of their unit IDs. As you can see, the OTAR encryption key is not loaded by this function. Lastly, let's talk about the CSKLD2 wired key loader. In fact, the CS-OTAR1 is capable of doing most of the things the CSKLD2 does, and suits most cases when AES encryption is required, even if over-the-air rekeying is not needed. But still, this could be a major reason for using the CSKLD2. As you remember, the maximum number of encryption keys in one key set is 31, if it's loaded by the CS-OTAR1. In other words, the radio can use only 31 different encryption keys for various destinations. On the other hand, the CSKLD2 can load maximum 64 keys into one key set. So if the radio needs to call various destinations with more than 31 types of different encryption keys, without changing the active key set, only the CSKLD2 can handle such a requirement.